You ever been walking down campus and you've had a friend look over you and say,
Hey, how tall do you think the library is?
I don't know. That's a good question. But I think we can figure it out.
So, what do we know about triangles? If you remember from last time, we studied similar triangles. In that lesson, we found that if you have the base and height of one triangle and the base or height of another triangle that is similar, you can solve for the remaining side. So, in our example problem of finding the height of the library, let's say we have a triangle whose height is, me, hello, and a second triangle whose height is the library, which we're trying to find. Now the question becomes, if we know the two of the sides, how are we going to figure out the bases? So what could we measure across the ground that everything has? Wait, I got it! We can measure our shadows! So let's put this all together. We start with a triangle with my height, 6 feet. And then we found out that my shadow is 8 feet long. Next, we measure the shadow of the building, which was 130 feet. Now, if we put those two triangles together, we now have something that looks like this. Now we just plug in the data we know. We know that I am 6 feet tall, and that my shadow is 8 feet long. And how long was our shadow of the library? 130 feet, good. Now, how do we set up the problem? Setting up the equation starts with two fractions. Put 8 on the top of 1, and then you have its ratio, the shadow of the building, on the bottom. And across from my shadow, I put my height, 6, and the height of the library that we're trying to find goes across from the 130. Now, we solve it by cross-multiplying, and we divide by 8 on either side to get 97.5 feet tall. Great job. We found out the height is 97.5 feet. Now, one quick note to remind you is that two things are not changing during this. My height or the height of the building. The things that are changing are our shadows, mine being 8 feet and its being 130 feet long. Those will change depending on the time of day. We've used GeoGebra in the past to mimic examples like this. So let's take a look at that real quick. So here's our GeoGebra example. As you can see, I've set it up with one small change. I've changed the scale so that 1/10 0.1 is equal to 1 foot. As I've set this up, my height is the segment EF, which is 0.6 or 6 feet, and the building is segment CA at 9.75, which would be 97.5 feet. In this example, the only thing that will be changing is the angle of the sun, which is shown in the upper left as alpha at 53.13 degrees. That would be this point right here. From there, if I were to take point D and stretch it out farther, as if the sun were starting to set, the angle would become larger and larger and larger. But as you can see, my height, segment EF, has not changed, and neither has the building's height at 9.75. But what has changed is the shadows. They've gone up to 33.12, and mine has extended even farther. From here, if we were to even think about it near high noon, let's say, if I were to drag the point all the way in, so that we have a really steep angle like the sun's directly over the building, my height is still the same, the building's height is still the same, but now our shadows have shrunk down to 2.5 0.3 into 0.16. So as you can see, our calculations were correct.